My name is John Rodriguez. I work at Block, formerly known as Square, on the Cash App team in a senior staff role. And I spend a fair amount of our time on the Cash team optimizing our Gradle builds.
My name is Tony. I work at Block as well, formerly known as Square. Recently, even in the Square org. I primarily work on the what we call the register repo. That is a team of 5 people, supports about 170 active developers on a code base of about 4,000 plus Gradle modules, 4 million lines of code. So that's the scale of things.
Whereas on our end, we have around 800 modules. So that gives you an idea of the relative size of the apps and the number of developers. You mentioned how many?
About 170.
Okay, and we're like in the 50 range. So it gives you an idea of 2 different products under the same company and how we've tackled these problems together. All right, so let's just jump in. The talk today is going to be on plugging into the Gradle matrix, which really is about Gradle plugins. Both Tony and I have, through different experiences working on the cache and register teams, have written Gradle plugins. And today we wanted to kind of share some of that knowledge. There's plenty of documentation on it. Some of it is incorrect. Some of it is outdated. Some of it is lost in the GitHub universe, and hopefully you find the right copy pasta to use. And what we're hoping is to consolidate some of that, mostly based on lessons learned. We made a lot of our mistakes too. But assuming you haven't ever written a Gradle plugin before, we wanted to just kind of tackle some of the early primitives that you might go through. So what is a plugin? Well, when you apply plugins, you add tasks to a graph. And the idea is that you're executing a command. Maybe you're building code. Maybe you're running a unit test. And all in that process, you're going to traverse a graph of tasks. A task is a block of work. It can be comprised of many actions. This is an example of a Java library, which is not what we do. We really have something like this because Androids have a variant system. And so this is just one app module with the default debug and release build types. And so you can see already we have a lot of tasks that could be added to the graph. And we'll be talking about how you can avoid actually creating those tasks until you need them. So before we start diving in deeply, let's cover some of the common plugin primitives. Tasks, what are they? Like I said, it's a unit of work. The canonical example, the Java compile task or Kotlin compile task. The output of this is going to be some class files, right? Inputs would include things like the source files, what's the target SDK for which you want to generate the bytecode, and then maybe something like max heap size. Max heap size here is colored differently because in Gradle talk there is a difference between task inputs, task outputs, and other properties that will bear no relevance, and we'll talk a little bit more about that. So that's what I just said, the terminology of inputs and outputs. And so if you run a task multiple times, there's this concept of if the inputs and outputs have not changed, then the task is up to date. That allows you to basically save some time in a build, in a portion of a build anyway. Going back to this now, if you substitute those variable names with something indicative of a build. You have a.java, you're passing it to the Java compilation task, out comes out a.class, the task is now executed. If you change the source sets by adding another source file, you would expect another class file to ensue, and therefore this task would again be executed. What happens if I hit the play button a second time now? Well, because the inputs and outputs have not changed, the task is up to date, as I mentioned earlier. What happens if we go back to the previous state? Well, it's not up to date because clearly the inputs and outputs have changed. However, if you enable this property, you now have a concept in Gradle called caching, whether it's local cached or if you have the benefit of a remote cache using something like Gradle Enterprise, it will know that while you didn't just do this, you have done this operation and the inputs and outputs have been saved. So that was a really high level on tasks. We're all experts now. Let's talk about configuration avoidance. So as you saw in that Android graph, for one module, it was already kind of hard to grok on that graph. Now imagine like a regular app, 20 modules, 100 modules, 1,000 modules. The exponential fan out of that graph is too big to represent on a screen. Now imagine your Java heap size, out of memory errors, your CI environment might be constrained. And so the ability to not create tasks ahead of time is something you should be striving for in your plugin development, but you will often find that sometimes it is challenging. All right, so here's an example of probably some code you copied pasted. Does anyone see any problems in this closure? Nelson, you know it, you know this already. You should not be using this, even though it's a very common example, because by copying this, you are going to eagerly configure the test task, the task that is named test, which oddly enough, will only apply to JVM artifacts. This will not apply to Android builds. The correct way to do it here would be to wrap it in a named closure, which would defer the configuration of the task until it's actually being used. As I mentioned, that using the explicit name test would only apply to JVM artifacts. If you're in Android, because of the concept of variants, you'd probably want your debug test and your release test, or whatever other build flavors and types you have, to be configured, and so you would use the type of the test name instead. However, this is also wrong, because just because we change it to the type doesn't mean that we avoided the configuration. Now, if you don't use the name, instead you use the type, you should just magically know that configure each is what you should use. And this is a common problem with plugin development. The APIs aren't necessarily consistent. Let's go to task definitions now. You've probably seen this a lot in Gradle tutorials. And did you know that these are exactly the same thing and that they're both wrong? You don't want to create tasks ahead of time because, again, thousands of tasks add up. And if you run Gradle help, for example, even though you ran Gradle help, if you eagerly realize a task, you're going to have the compilation tasks, the resource merging task, the dexing task, all in memory resident and configured, and you will never run it. And then your daemon will hold on to it over the lifetime of multiple builds. This is the proper way to do it. You should register your task. If you actually look in the Gradle source, it will become more obvious why that is, because the create method returns a type of task, whereas the register method returns a type of task provider, essentially a lambda that will one day give you a task should you want it. I filed an issue with Gradle, actually a PR, to maybe deprecate the methods that we should no longer be using, because deprecation is a good JVM way to indicate don't do this. It is still pending, and those methods still exist undeprecated, so here we are. In the meantime, if you did use that register method and get back the type of the variable of the instance of a task provider, realize that it will not be it won't be an instantiated task until you call get on it. And this is a theme that we're going to return to oftentimes, because sometimes you might be calling get when you didn't want to yet, and there are only certain times where you should call that get. If you do use Gradle Enterprise, or if just you've used a build scan on an open source project, you might be familiar with this screen. And if you go to the Performance tab under the configuration or dependency resolution, I think it's configuration, you'll see that there are some handy little widgets here, line items rather, that will tell you whether you're doing things right. You should be striving for tasks not being created until they're needed, and that should make sense. But as I mentioned, it's often challenging. The Kotlin plugin itself violates this. Now let's move on to another primitive very common in plugin development, properties. So the idea of a property is that instead of realizing a value, instead of getting a value that could be computationally heavy and not always used, you wrap it in, again, something like a lambda. And in this case, the provider is one's instance of that. A provider is a read-only value. So if you're looking in tasks from the Android Gradle plugin or the Kotlin Gradle plugin, you're not going to mutate it. It's something you're going to depend on downstream. And so read-only providers make sense here. If you're, however, creating your own tasks in your own plugin, you'd probably want to mutate it internally or allow customers to mutate it via, say, an extension, which is like the DSL, the name of how Gradle's DSL model works. And so a property would be the way to do that. And again, this would just be a lambda around some potentially computationally heavy task. Other popular properties you might come across are things like file collections and file trees, essentially the difference being a set of files or a recursive walk of a directory. And then the mutated versions, the configurable file collection, and then something that represents a file, a directory property. And we'll see why these are helpful. So a small example, let's say we just want to write two tasks, a producer and consumer task. And we want to wire them up. So here are the definitions. We create our task providers instead of our tasks, like good Gradle plugin developers. And now the thing to point out here is that we are now mapping the producer to the consumer using that closure, input file.set producer flat map. This is how we are now linking the two tasks to depend on each other. The consumer depends on the producer by means of it depending on the output file of that producer. You may have, if I go back, you may have noticed in the past some tasks will explicitly depend on another task. You may have done this yourself in your plugin development. However, you should probably avoid this too. If it's internal to your plugin, you could probably get away with it because you know the details better than anyone. But reaching into a third-party plugin and saying depends on is a bit of a smell. What if that plugin changes its implementation detail? You basically couple to an implementation detail by doing so. Also, Gradle's smarter now. It's able to infer this. If you depend on the output of a task, of course you depend on that task. Why would you need the explicit dependency otherwise? So one corollary to this, if you use the provider system, which you really should, you will get task dependency manipulation for free. There's an open source project I maintain called Paparazzi, and in fact, we had a bug similar to this because if you look, we basically in Paparazzi can run in several modes, one of which is record and verify, and we were getting handles to the task provider, but then when the task graph was ready, we wanted to essentially know, based on the Gradle state of the world, what parameter do we pass to the ultimate JUnit rule that runs? And in doing so, we were accidentally realizing the task early. An open source contribution fixed that by inverting this, and so similar to if Kotlin, functional programming, or RX Java, if you want to have a lambda containing a future value, but you want to depend on some mutation of that value or transform of that value, there are map functions and flat map functions to provide that for you. And with that change to Paparazzi improving the task realization, we saw that we reduced significantly, about 290, if my math is correct, how many tasks we were. So you think of Paparazzi running 3 or 4, or configuring 3 or 4 tasks for every view or composable module that you have in your application. This quickly adds up, and we were kind of abusing our heap size on CI and local developer builds unknowingly. Let's talk a little bit about task dependencies. And so we already talked about one example where a producer can depend on a consumer simply by depending on its output. A more common example, again, not great, but very common, is to depend on the compilation output of either the Java compiler or the Kotlin compiler. Or if you depend on Kotlin multi-platform, whatever output is specific to the platform you're working in. While not great, this is the only way to do it currently because those respective plugins aren't using the canonical way, which we'll talk about in a second. AGP, the Android Gradle plugin, used to have a way to do this. The variant model, which there are two things. There's a difference between Gradle variants and Android variants. The Android variant is what we talked about before, your debug, your release. Maybe you have like a paid or free product flavor, and then there's a matrix of how your app can be built. And in that Android variant model, it used to provide handles to tasks. Again, leaky abstraction. You shouldn't be depending on internal details of the Android Gradle plugin. But for a while, if you wanted to do anything custom, that's what you had to do. And so here's an example of where we do that in Paparazzi, and we should probably stop. Here's another way. If you wanted to say not depend on the APK or the resources, but rather some really internal detail, like maybe you're using non-transitive resources and you want to know all the R classes that exist as a result, Paparazzi actually has to do this in order to effectively render your views. Then you can jump into the Android Gradle plugin's build intermediates directory, which right away that should be a red flag, but we do it, and look at an artifact that AGP isn't advertising. So don't do that, but unfortunately now, at the moment, it has to be done. That being said, the Android Gradle plugin is trying to improve on it. It's exposing APIs more and more. More recently, if you look at their repo for Gradle recipes as of AGP 7x, 7.2 maybe, there is something called a built artifacts loader where you can ask AGP, hey, I want an artifact of type this, where this could be an AB, an APK, or your assets, your resources, and hopefully more artifacts will benefit from that. And so you can do stuff like this as a result. The really, really cool way and correct way to do this is unfortunately a little bit of a dark magic. Gradle, not Android variants, but Gradle has its own way of providing variants where A module can produce many different outputs depending on how you invoke it. So if you have an Android artifact, you can not only consume its jar and publish it to Maven Central, but you could also just consume its class files, because why would you package the jar only to unzip it in a downstream task for the purposes of compilation linking? And so it's common for, this is done under the hood by Gradle, but you yourself could publish an artifact and then have another downstream module ask for, hey, does anybody publish the artifact of this type? And Gradle will do the matchmaking for you. And this is the right way to decouple tasks and modules from each other. There are equivalent reports provided by Gradle that will allow you to see what a producing module does allow as an outgoing variant. That's the terminology, unfortunately. And similarly, what the consumers will take in. And just to go back there, this is how, in this case, the producer and the consumer will not be a match, because the producer is producing a jar and the consumer wants an instrumented jar. Another advanced concept of Android Gradle plugin development is the worker API. So when Gradle, one of the things that it does is it sets up these task dependencies so that later on when it's running a command can traverse this graph. How does it traverse it? Well, as you would expect graph traversal to work. However, at the moment, unless you operate in a certain fashion, two tasks cannot run concurrently within the same project unless you use the worker API or, as I was informed earlier, using configuration caching. Just by the nature of making your project configuration cache compliant, you get this for free. But previously, in order to have a task in one module and a task in the same module, not in different projects, run concurrently, you had to use this thing called the worker API, which is essentially was a way of doing parallelized execution of work. Unfortunately, it's a bit boilerplate, but the benefit is you know exactly what you're doing. It forces you to work in a certain paradigm that is like foolproof. There are no side effects as a result, or rather the best practice is the side effect. But as a downside, there is a lot of boilerplate. A need that may come up as you develop your own plugin is the concept of a singleton, right? Something that's resident in memory that one project task can mutate some state so that a downstream task can consume it. You could write to the file system, or you probably want to keep it in memory. If you do the latter, you don't have Dagger components or anything like that. Dependency injection is kind of baked into Gradle with the add inject annotation, but remember that Gradle daemons can last between builds, and so you probably don't want to inadvertently create a memory leak. You want something that's like a singleton, but for the lifetime of your build, not for the lifetime of the daemon, and this is where a build service comes in. And so Tony actually uses this in his plugin, the dependency analysis plugin, where he wants to keep some in-memory cache state, probably for like processing jars or any other graph traversals. And yeah, so this is a thing to know about if you really want to start getting heavyweight in plugin development. Once you have that build service, you can register it. Gradle will automatically know the first task that will register it. As long as you register the task to the service, you just say, hey, I am a task that uses this service, and essentially there's something like a countdown latch or a semaphore internal to Gradle. We'll say, okay, 5 tasks use this, and when the last task is no longer needing the build service, I can shut down the build service independently of the job. And so it's a nice way of managing that for you. It really is the only safe way to do it. I originally was doing something similar using companion objects in my plugin class, and then I realized, oh yeah, daemons are a thing. If you don't pass -- no daemon in your command, you essentially leak memory. And depending on what it is that you were storing in your build service, that could probably be really large. Okay, so we have an idea, hopefully, of some primitives. I know we covered that really quickly. We went from simple stuff like tasks and properties to like more advanced stuff like worker API and build services. Let's look at some real-world examples. So on the cache team, you might have heard in previous like Google I/Os or Android summits that there's always this desire to like show your Git commit or your Git timestamp in your debug drawer because Jake Warren made the U2020 project and it did it in that, so let's just use it because that's a cool thing to have. And then you realize that you were probably slowing down your builds because it was being configured at all these times, and AGP at the time didn't really have a way to pass dynamic values to your build config in your manifest or in your build.gradles in a way that was lazily deferred. You pretty much had to call Git in an I/O process, block your build, get the data, and then publish it for something that you didn't need all the time. You really only needed it when you were building your APK, right? Because you only see the Git SHA in your debug drawer, not when you're running unit tests. And so there were many attempts to do this, and we had the same problem. We were literally running Git commands all the time. And so the way that we fixed that is first, AGP now has a way to provide providers, both for build configs and for resource values, dynamic resource values. We did realize, however, we did not want to put it in build config because we wanted to optimize for dexing. As your app gets really large, you don't want to recompile code as often as maybe you don't mind merging resources, especially as we move from XML layouts to Jetpack Compose, which should be reducing the number of resources that we package in APK by a lot, basically drawables and strings maybe. And so in that fashion, we moved our dynamic Git SHA stuff away from build configs to a resource model. And to do so, go into the AGP, run the Git command, set up this stuff so that when you run the Git command, you can dynamically add it as a resource value, and then voila, in the actual task that you create, run the Git commands, and because you're running the Git commands in a task action, that's the only place, that's the only safe space to run your I/O actions, to call your task providers.gets, and to do all the things that might be intensive, because this is where Gradle will actually manage it properly. So why do we care about all this?
Okay. First, a bit of bookkeeping. I see people taking pictures. We will be putting this up on the internet later on, so feel free to just defer that, and you can grab it online later. So why do we care about all this stuff? This is a lot of information. A lot of us are just Android developers, so we really care about the ins and outs of Gradle plugins. You are here, so maybe you do. But here's why we care. So first of all, to reiterate, my team is sort of like the maintainer of the Android, or the Square register monorepo. It's one of the biggest Android monorepos in the world, has many build targets. One of the most famous would be the point of sale app, and Reader SDK, for example. And what you're looking at here is our daily benchmarks going back over a couple of years of different scenarios. So we use Gradle Profiler to benchmark the build of various verticals, and so each of these colors is a different scenario. So what I'm going to show you here is a series of events. So July of like 2020 or 2021 or something, soon after I joined, we converted our build source into a composite build, and that immediately created a bit of a regression in build performance. We lost like 30% of our time to configuration. So that happened. But then, let's see, when it went down again like a few weeks later, that was because we started publishing our build code. So we transitioned from having all these ad hoc script plugins to converting that to build source, and then from build source to a build logic included build. Finally started publishing that to our internal Artifactory, and then just resolving those plugins like normal binary plugins third party out in the world. And that ended up being a lot faster. You see that it went down soon after that. The next thing that happened in this timeline was, I have no idea, I don't remember. It took us a few weeks to recognize that we had introduced a build regression. We fixed that just a little while after that. The next thing that happens in this timeline is KGP 1.7, that's Kotlin Gradle plugin. That had a major regression, but we couldn't avoid it, so we just bit the bullet and just took it in. Later on, KGP 1.7.10 fixed the regression. Good for them. And then finally, at the end of this timeline, we made our build configuration cache compliant, and you see that it goes down a lot. And the other little spike is just noise in the data. But the story I want to tell with this graph is, over the past 2 years, absent a couple of regressions here and there and some noise in the data, there is a downward trend in time spent building our verticals. And that's actually a really amazing achievement. The build has gotten linearly bigger with time. More lines of code, more modules. Every day it gets bigger and bigger and bigger. And even with that, we've gotten the build time down more and more and more. That's because we've been laser focused, other than that one whoops, on keeping the build getting faster all the time. And so that's why we care about Gradle best practices. And now, the number one super secret performance pro tip. So we love Kotlin. But we don't love Kotlin because of its build performance. That's all I'll say on that one. I think it's back to you, John.
Yeah, let's talk about
Okay.
some convention plugins. So, you might have heard about convention plugins, right? We've been talking about plugins. What are convention plugins? And so, another optimization that you could make historically is, all right, you have a multi-module project. You have all that Android configuration in every single module, and that just seems redundant, and people don't understand what they need to do. Like, they know how to bump a dependency, but they don't necessarily know, like, you need to set for different locales in a certain portion of the Android DSL. And so one bright idea you might have had is to extract all that build logic out of each individual module and put it in your root build.gradle into something like a sub-projects or an all projects block. It was great at the time, but now you shouldn't do it. Why? Well, we'll talk about project isolation in a bit, but there's a project that essentially says in order to run Gradle at its maximum efficiency, no module should ever be tied into its parent module. You want basically every Gradle module to almost act as if it's its own repo. And by having a sub-projects block or an all projects block, you defeat that. Well, that's a little dissatisfying. I was trying to use dry principles and move everything out of my single Gradle files, rather all my Gradle files, and put it into one place, and I'm happy that I did it. Now you're telling me that's wrong? Well, it's not that it's wrong, it's that it needs to change how you do it. Essentially what you want to do is you want to move that logic back temporarily into the individual Gradle modules, right? So here you have it. But then what you want to do is essentially the equivalent of an extract method. You want to pull that all out, but now move it into a convention plugin. And so just like in code, when you have too much code in a method, you extract it using Option Command M, and voila, now you've moved the common logic into a function. I want you to think of convention plugins or as essentially doing the same, but for Gradle build script code. And if you accomplish that, your build script code does become as simple as applying your plugin and adding dependencies as it should. You can leave all the complex tuning to whoever the senior or the Gradle gurus are on your team. Let them handle that. That's what the convention plugin is for. That's their playgrounds. And then you can focus on just managing your module and working with it. And so how would that look like is essentially you would declare all the plugin IDs that you'd be using. You can set your own hierarchy. You can start saying, hey, I have an architecture where there should only be composables in this module, and there should only be presenters in this module. And then using convention plugins, you can infer, all right, since this is an only composables module, I can use paparazzi. I can just apply the plugin. No one now needs to add apply plugin paparazzi. Just by using the composables plugin, my convention plugin, I just get it for free. You start to now apply standards across code bases in a plugin fashion. And so that's kind of nice. And so that's what we do here. In our views modules and our composables modules, you just get paparazzi for free because you wouldn't use paparazzi in a presenters module. You wouldn't use it in a view models module. It just makes sense. You can definitely add a little bit more and have just configurations embedded on there. I know Tony will talk about some of how they do that on register. But one thing I want to talk about is Kotlin DSL, or rather Kotlin build script. Should I use it? Like build source, build gradle.kts. That's great, right? Because Kotlin, meh. And I'll tell you why. I don't love Groovy. I do not. I love Kotlin. But KTS files compile poorly. Build sources will just ruin your build performance. And I think that the best incentive to ensure that you're working in Kotlin in your builds is to not use KTS files in each module, but rather use convention plugins and write your convention plugin in Kotlin. You're gonna get the same effect. You're gonna, basically your Groovy build.gradle is just gonna be, if you do it right, dependencies. And I think we're okay with that. I think we're cool. Just have a TOML file, put your Gradle dependencies in there, put it in your block, done. You don't have to know the innards of Groovy, but your builds will love you for it, and so will the rest of your team. So again, if you achieve this, you'll get a convention like this, and this is something that you would know about.
Yeah. I just want to quickly go back to this slide just for a second. So this is like my platonic ideal for a build.gradle file. It's a plugins block, it's just some custom convention that you have, and it's your dependencies block, and that's it. It's simple, readable, maintainable, and verifiable, importantly. You could write a really simple grammar to parse this and just lock it down on CI. And then your app developers can't do stuff like this. So I don't trust app developers. I'm sorry, it's just the truth. This is a legitimate build.gradle file. You could copy and paste that right now, and then you could sync that in your IDE, and it would literally start a local web server. So you can do anything you like in a build.gradle because you have the full JVM available to you. You have the JDK, you do whatever you like. And so because that's possible, it's really important to lock that stuff down. And that's what we do on Register. We have a CI check that verifies that our build.gradle files follow a certain convention, and if they violate that, the build fails and the PR can't go through. And that's again, this goes back to that benchmark slide I showed a while ago. The reason this is so important, and we have such a large build, and it's gotten faster with time, that's because we've been so anal about keeping the build scripts really clean. So let's do a quick case study. So many of you may know that I am the author and maintainer of the dependency analysis Gradle plugin. It finds unused dependencies, it finds used transitive dependencies, it finds misdeclared dependencies, and it works on multiple ecosystems, Android, Java, Kotlin, Groovy, Scala, Spring Boot, etc. It's unique. And it is, for me, a sort of like sandbox for best practices. It's something I'm always sort of fiddling with and trying to make as clean as possible, so it's a good exemplar for people who want to learn about Gradle plugins, and it's written many blog posts about it as well. So here's an example of something that's bad. Don't use after evaluate. It's just not great. This is the preferred alternative. And the reason for this is because when you use after evaluate, you're introducing ordering issues into your build, into your plugin. And you don't want to have any ordering issues because it's going to cause you pain. It always does. There's a couple tickets on my plugin because I have to use after evaluate in a few cases, and it's always a pain in the butt. It's the truth. So Gradle is kind of like a case study in class loader hell. This is another valid build script. Drop out in your build.gradle, just configure it, and what you'll see is something like this. Now, don't try to read that. That is just a hierarchy of 10 class loaders, all of which influence your build script. That's a lot of class loaders, and it is going to cause you pain if you have any kind of non-trivial build, which is basically everyone in this room. Even the smallest consumer app is going to have a class path issue at some point. And so it's really critical to minimize your dependencies in your build scripts and in your plugins, because you want to avoid this kind of the kind of shenanigans that can result from having so many class loaders that are available. So here's a horror story, something that really happened on the Register repo. There's these two separate libraries, protobuf Java and protobuf Java Lite. They are different coordinates, they're different dependencies. Gradle thinks of them as totally separate, and so you can put them both in your build script, and that's not a problem. Gradle will let you do that. However, if you were to unpack those jars, you will find that they contain some identical class files. Well, the same file names, they're not identical because these class files have different internal contents, right? And so depending on which of these class files gets loaded first, and remember there's 10 class loaders here, so you don't know where it's going to come from, you will have a different class loaded in your build script, and your build is going to fail at some point. And that happened to us, and it's one of the reasons we started using Dropbox's dependency guard plugin. I don't know if anyone from Dropbox is in the room, but thank you for that. It didn't exactly solve the problem, but it did help visualize it. Because when you see protobuf Java and protobuf Java Lite side by side, you're like, that looks like a smell. So yeah, that can happen. Keep your dependencies minimal is the sort of name of the game here. One of the sort of more advanced techniques for managing dependency issues with Gradle plugins is just to shade them. There's pros and cons to this approach. It can bloat your plugin size considerably. So for the dependency analysis plugin, there was a time when I was shading things and getting like, I think the jar was like 18 megabytes in size. I eventually got it down to 3 megabytes with some more judicious shading. But it's unfortunately required in some cases because there's some dependencies that are just too useful to not use. One example of this is the ASM dependency for doing bytecode analysis, something that I do a lot of. And everyone uses it. If you look at, if you just do like a double tap shift on your IDE and type ASM, you're going to find that KGP uses it, AGP uses it, and a few others also use it. But they all use their own internal shaded version of it because they all know that there's going to be conflicts. Because that library undergoes a rapid development and the bit rot is considerable. And you don't want to deal with the wrong dependency version, basically. What do we have here? Okay, so this is just a simple slide. This is an example of how you would configure the shadow plugin to shade one of your modules if you had to. The bit at the bottom is a bit of a black art. Think of that as a stanza. So I use that to basically say, I only want the shaded version of this artifact. Everything else, just get rid of it. And if you go to the URL there, you'll see it in context. It'll help you understand it a bit better, but just for reference. Another best practice for plugins is if you have an optional dependency, you should use compile only and not implementation. And the reason for that is, so for, again, for my plugin, the dependency analysis plugin, it works on both the JVM and on Android, and so I don't want to have a hard dependency on AGP because my JVM users will be annoyed. And so I use compile only, and by the way, that is not a typo. My plugin does in fact work down to AGP 4.2, as well as up to 7.4, I think. And so we'll talk about how that's possible in just a little bit. But yeah, so you use compile only. Who here has experience testing Gradle plugins? Love it, okay. Still a minority, but I'm glad to see you guys in the room. So we're gonna talk about functional testing now in the last 3 minutes of this talk. Let's go quick. So this is just an example of using a modern, I think this is still considered incubating. This is the JVM, Gradle's JVM test suite plugin for, let's move on. Well, not a lot of time, yo. So I want to remind you that there are other languages out there besides Kotlin. Groovy is not so bad. Drink the Kool-Aid. I really like the Spock test framework. It's, I think, the best test framework on the JVM. The BDD style is really nice. And importantly for this talk, parameterization and data-driven testing is really easy on it. So here's a simple example of a Spock test, a Spock spec as they prefer. This literally creates a Gradle build and then runs it as part of your test invocation. And so this is literally an example from the plugin that I will hopefully talk about in a little bit. This is how to use TestKit. Yeah, kind of keep going. Okay, this is a more interesting bit. So this is the data-driven test. This is a simplified version of what I use both at Register and in the dependency analysis plugin. It lets me test those plugins against a suite of different third-party artifacts. So in this case, we're showing an example for AGP. This lets me verify that my plugin works for AGP 7.0, 7.1, and 7.2, all in the same test invocation, which is really nice. It's very convenient. I'll see immediately if I've made a change that will break my plugin in any of these versions without having to do any kind of like bash scripting to wrap it in a loop or something. And this is possible because of using the compile only versus an implementation and some other sort of dark arts that there's very many examples of in some of the URLs that are in this slideshow. But yeah, so this is, I love Spock for this. It makes it so easy to do this kind of testing. One important part of this is, if you remember the slide just back here, we use this with plugin class path method as sort of a magical way of injecting the plugin's jar onto the test class path. When we do our approach of having the data-driven approach, we don't want to do that because we want to have more control over the class path. Yeah, so one of the things you would do is you would publish your plugin to a local Maven repo. It gives it a more natural feel. It's more like how your consumers would use your plugin. Here's a code example of how that works. We will not go into it right now. This is a, yeah, I'm going to skip this stuff because it's kind of advanced. We don't have any time. But basically, Register does a whole thing where it wraps AGP, and then we can test against various versions of it, and it's pretty cool. That's an example of why it's important. This methods change from time to time, and we want to make sure that our code is going to work for forward versions of AGP before they get released. This is, we only have 30 seconds left.
That's fine. We could go like a minute.
Okay. So this is a concept that I like a lot. It's a nice pattern for when you're writing plugins. It's a typical use case where you have a computationally heavy task you need to do. You need some bytecode analysis, for example. You want that to be as fast as possible. And you also want it to be build cacheable so that you don't want to rerun it too often.
So you make that task cacheable, and it spits out a report to disk. That's what the bottom line is there. It just writes the report to disk as a JSON or whatever. And then you have another task, which I'll call, in this case, a print task, that just consumes that information and prints it to console. Because this task only has an input and no declared outputs, it will always run. So that's a way of having your cake and eating it too. The compute task will be cacheable, and the print task is going to print to the console. That's like your UI for your developers. They'll see what the result of that report is. That's just wiring it up. It's another example of similar to what John showed earlier. Okay, so configuration caching, super. You guys got to be doing this right now if you're not already. We estimate that we save 5,400 hours of developer time annually, easily over $1 million in savings. A blog post is forthcoming on this subject. The configuration cache has been just a huge savings for us. Yeah, it's just, I can't talk more highly about it. It's technically still considered unsafe, but by the end of the year, Gradle intends to have it be GA, I believe, before Gradle 8 is released. And it's also a necessary pre-step for project isolation. Here's a simple, straightforward example of testing that your plugin is CC compliant. Not only that, it can write to the configuration cache, but also pull from it. So yeah, that's testable, and you should test it if you have a non-trivial plugin. As we've mentioned a couple times, I think in this talk, there's this concept of project isolation. I think that's Gradle's big focus for next year. Thank you all for coming.